right, example 4 from 3.3. A student council at a high school is planning a fundraising event with a professional photographer taking portraits of individuals or groups. The student council gets to charge and keep a session fee for each individual or group photo session. Last year, they charged a $10 session fee and 400 sessions were booked. In considering what price they should charge this year, student council members estimate that for every $1 increase in the price, they expect to have 20 fewer sessions booked. So write a function to model this situation, and we'll find out what the maximum revenue is. Okay, so when we decide how to write a function, we have to say, what are we changing, and what are we looking at, what quantity do we want to see how that change is going to affect that quantity. Okay, so what we want to know is, how does our revenue, we're looking for revenue as a function, and as a function of the price, okay, but more specifically, we're trying to decide how many $1 increments we should increase it by, okay? So we're looking at revenue as a function of basically the number of $1 price increases, okay? And so that's what allows us to, because if you just put the number or the amount of the price increase, it gets a little more complicated. Okay, but if we just look at the number of $1 price increases, we can see what the new price is quite easily because we just have to add $1 for every one of these price increases, add that to 10. And we also know that each one of these $1 price increases will result in 20 fewer sessions booked. Okay, so let's let n equal the number of $1 increases. Okay, that means that our new price is going to be $10 plus $1 times the number of increases. Okay, and then we know that the number of sessions booked is going to go down. Okay, it's going to be 400 like we had last year, but then we're going to lose 20 for every one of those $1 increases. Okay, so if we have two $1 increases, a $2 increase, we're going to lose 40, right, etc. We know that the revenue is going to equal the price, okay, price per session times the number of sessions. Okay, and we have expressions for both of those. So R is going to equal 10 plus N, okay, times 400 minus 20n. Okay, we'll distribute that using FOIL. Firsts is 4,000, outsides negative 200, and insides 400, and the last minus 20n squared. Okay, we will rewrite this, and we'll write it in ax squared plus bx plus c form. So negative 20n squared, okay, plus 200n, because we grouped those two like terms in the middle, and plus 4,000. Okay, and so we know that this is going to be a parabola that opens down, so we'll have a maximum, which we kind of figured because we thought we'd have a maximum value. Okay, and you know our maximum is the vertex, so a good thing to do here, this is for B, to find the maximum revenue, okay, and what session fee will give that maximum. We can change this to vertex form by completing the square. So let's take a factor of negative 20 out of the first two terms, okay, and so that's going to leave negative 10n. You can verify that negative 20 times negative 10 equals 200, okay, so we know we did that right. Okay, I'm going to put this 4,000 over here because I don't want to forget about it. Okay, I complete my square by taking negative 10 and dividing it by 2, or taking half of it, which is negative 5, meaning I need to add a 25. Okay, and what have I actually done? Well, I've actually added negative 20 times 25. Okay, so I've actually added a negative 500, or subtracted 500, and I'm going to undo that by adding 500. Okay, and then when I rewrite this as a binomial squared, I get n minus 5 squared plus 4,500. Okay, and so now I know what my vertex is, right? Because P is 5 and Q is 4,500. Okay, and so since this is the revenue, okay, that's the Y value, right? And we're looking at revenue as a function of number of price increases. Okay, we now know that we could actually increase the price by $5, okay, and we will get maximum revenue, okay? So 100 less people will book sessions, but we are going to have maximum revenue, okay? The price per session should be $15. Okay. Oh yeah, it doesn't ask, the question is what session fee will give that maximum, okay, not the price increase, so the session fee of $15 gives maximum revenue of $4,500. Okay. All right, and you can verify the solution using graphing technology if you like. Okay, you can show how, yeah, we'll just punch it into here. Okay. And one thing one problem with this is that if you haven't set up the equation properly, then, you know, the graphing calculator is really not going to help you to verify. Okay, you can verify your solution of your equation, but yeah, I mean, if you did it wrong, if you set it up wrong, it's not going to catch that, right? I'm going to actually do it with our very first equation before we completed the square, before we did it. You know, go back as far as you can anyway if you're going to verify it. So 10 plus n times 400 minus 20n. Okay, I'll just graph that, and oh, it probably wants x, right? So I'll just put x. Okay. And so we will zoom out again. Obviously, we have to zoom out a lot, and in fact, I am going to change the settings. Okay. Make my minimum x-axis value -10 and my maximum, well, last year we had 400 sessions, so we'll make my maximum 500. And then my y-axis will make a minimum of -100 and a maximum of 5,000, because I think that's kind of where my values are going to lie. Okay, and then I can graph it again. And, sorry, my mistake. The x value is the increase in the money, right? It's not the number of sessions booked. Okay, so if we graph that, you can kind of see where the peak is, all right? And if you look, yeah, it's maybe about there. Okay, so we're looking at, it's about halfway between 0 and 10, right? So you can see the peak is probably at 5 and 4,500. Okay, and I'm not exactly sure how to show the coordinates of a point on there when you're tracing it, but that's okay. Okay, what assumptions did you make in creating and using this model function? Okay, well, one assumption, a big one, is that they kind of assumed that, or they estimated that they're going to have 20 fewer sessions for every $1 increase in the price. Okay, and that's kind of I don't know where they came up with that. Okay, other factors they say in your book are how happy people were with their photos last year and whether they tell others. Okay, whether it's going to become more or less popular. Whether they advertise the event more, whether the photographer is the same or different. Okay, the date, time, and duration chosen for the event. I thought of another one, but I can't remember what it was. But yeah, so there's a lot of different assumptions. And oh yeah, and you also assume, I guess, that their main goal is price as opposed to having this available to as many students as possible, because, you know, in some school divisions, they would rather just make it so that it was something everyone could do, and they would gladly make $500 less and have a whole bunch more students book their sessions. Okay, have 400 instead of 300, be able to take advantage of it. Okay, so that's the end of that example.